Hello students. Next topic that we are going to discuss is quantum mechanical tunneling. So till now we were discussing about the quantum mechanics of a particle which is trapped in a box or which is trapped in a potential well. Now we are going to discuss about a particle which is approaching a potential barrier or potential hill. It is not about a well, it is about a hill. A potential hill is there and a particle is approaching that hill. You can see in this figure that there is a particle that is this is the particle, it is moving in this direction, and when it move in this direction it will see a potential hill here. So if the energy of the particle is not enough to move over this potential hill, it cannot go beyond this hill region. Okay, now this is the case of a classical mechanical thing. Okay, so you can see a classical ball rolling towards a hill or a potential barrier, but it cannot go. If the ball has energy E less than the potential energy barrier, that is potential energy barrier U ആണ്. U എന്ന് പറയുന്ന energy that is equal to mgy. You can see that here the height is y. So mgy is the potential energy barrier. E is the energy of the particle and it is less than the potential energy barrier. Then it will not get over the hill. That is the classical thing. So the other side of the hill, this is the other side of the hill, that is in this region. This is the other side of the hill, and that region is a classically forbidden area for this particle. So for this ball, this region beyond this hill, potential hill, is a classically forbidden region. Now what is quantum mechanical tunneling? So there is a different explanation for this same problem in quantum mechanics. So when you consider the same thing in quantum mechanics, if a quantum particle is approaching a potential hill like this, and if the energy of the particle E is less than the height of the potential barrier, then behavior of the quantum particle at the potential barrier is different from the behavior of the classical particle at potential well. So when you solve the time independent Schrodinger equation for the square barrier problem, it will give some result. And if the quantum particle has an energy E which is even less than the potential energy barrier U, there is still a non-zero probability of finding the particle in the classically forbidden region. So what we have explained is, in the classical mechanics, this particle which is having energy lesser than that of the potential barrier or potential hill cannot go beyond that hill. The region beyond that potential hill is a forbidden area for that particle. But according to quantum mechanics, there is a non-zero probability of finding the particle in that classically forbidden region, and this phenomenon is called tunneling. More specifically, you can call it as quantum mechanical tunneling. To see how this tunneling is working, we have to work with the time independent Schrodinger equation, and in this figure you can see that the particle which is approaching this quantum mechanical potential hill is having a wave function which is represented by this region, and when it reaches this potential hill area, potential barrier, this wave function as such is not getting transferred into this region, but you can see an exponential decrease, exponentially decaying wave function in this region. Okay, so this region is the representation of quantum mechanical tunneling. Okay, the particle emerges with the same de Broglie wavelength after tunneling through the energy barrier, but its amplitude is decreased. So after this tunnel region, the wavelength of the particle, which is equal to de Broglie wavelength, is the same, but it will be different in amplitude from the incoming matter wave. Okay, so that is the preliminary idea about quantum mechanical tunneling. Quantum mechanical tunneling means it is a process where a quantum particle which is having energy E less than the potential energy barrier U probability when this quantum particle having energy less than the potential barrier approaches the potential barrier, there exists a non-zero probability for the particle to exist in the region beyond the potential hill, or it can tunnel through the, in a way